Hey folks, the end of the semester is getting close, so I think at this point it will make sense to start looking into how we can turn those surfaces actually into printable 3D geometry. And there are two options we have here. We can do everything inside Blender, and we can also utilize Fusion. And each approach has certain advantages or disadvantages, more steps, less steps, and step by step I will just introduce you to those different approaches or workflows you can utilize. And the first one will be how to do everything in Blender. So you don't have to export all the geometry to a different software and then rebuild your design. But before I show you how to do the how to create the surface and the volume in Blender, I would like to go back one step and actually spend a little bit more time on the shrink wrap modifier, which I demonstrated to you last class. So the shrink wrap modifier, as I demonstrated to you during last class session, is actually a tool that allows you to project a surface or geometry onto another object. And think about it like digital tape drawing. Like in real life, if you, for example, have a car profile from a side, you have a huge piece of paper, and then you take black tape and start drawing those profile studies. And we can actually do the same just digitally, as you can see here, by modeling those profile lines and then actually projecting them over a three-dimensional surface. Now let me show you the different steps we have to use for the shrink wrap modifier. So for example, here you can see this is my very basic geometry input for kind of like where maybe I would like the parting lines to be for the front door, the back door, the trunk, etc. And you also see that when I turn on N to go to mesh display, that my normals are all facing one direction towards the car. And you also see, for example, the Y arrow. So the Y axis goes perpendicular to the car side. Those are important elements to keep in mind. Now let me hide everything else besides those two objects. So the first step is actually to add a subsurface modifier. And the main reason behind this is I have very coarse input geometry, and with the subsurface modifier I'm creating a much denser mesh. And this much denser mesh I'm going to pass to a shrink wrap modifier. Now, to explain actually the origination of the shrink wrap modifier, it is actually a technique that goes back to character animation. Imagine you build a digital character and then you put like a t-shirt and pants on it, and then you animate the character. Well, you want to not have to animate also like the t-shirt and the pants when you move your character. So you want to have a system where you just focus on the movement of your character and the cloth actually follows it. And that's basically where the shrink wrap modifier originated from. However, a car is geometry and a character is just geometry, so it doesn't really actually matter what you use the shrink wrap modifier for. If you project a t-shirt onto your body, or if we project tape lines onto a car body, it's exactly the same. So it's a nice tool actually from character animation, which we can utilize here for our design process. The shrink wrap modifier interface has kind of like a target So for target, for example, this is our target. So this is, the name is car body 003. So for example, I can type in 003 and then it filters out car body. And yeah, it looks a little bit garbage. Because the mode we want to select is actually project. And the moment I select project, you see it looks much better. We have the ability to create an offset. So that, for example, the surface sits on it or it goes inside. And then I have an option for direction, positive or negative. So positive means along the surface normal, and negative means, well, the opposite direction. And so with negative, for example, you don't really see anything because the normals are facing this way and my car is behind. So you see when I move the object to the other side, then the projection is on the car body again. And if I move it back to here, then I have to select positive, and then that's there. So that's basically sorry, how the shrink wrap modifier with its basic setting works. And here is a function axis, x, y, and z. And this basically is kind of like a constraint. So like when you move something, for example, if I have a cube and I click on the green arrow, I only move it along the y-axis or the z-axis. And the same, we can also tell the software to only use one axis, for example, for the projection. This sounds a little bit confusing right now, but let me show you a very simple example. So I'm going to create a plane. I'm rotating it 90 degrees, scaling it down. Maybe I move it to here. Then let's add just a subsurface. Oh wait, no, actually, no. Just go very simple. Shrink wrap. And I'm give this piece a color so you see better what's happening. Car body 003. Project. A little offset so you see where the part is. Okay, so this looks not too bad. So let's say I select this upper edge and I extrude something out. And maybe I extrude something further out. You see that actually it flows over it. And if I now extrude something out another time, you see that at one point the software gives me a bad result. And that is because actually you can see if you follow the Y arrow, there is nothing there. So if I, for example, now move actually this point over to there and press Y and E and Y, you can see that I actually can make the surface, follow it. And the main reason how this works is, again, the normals are the key. So you see each face has its normal, and whatever is below this normal, the surface is being projected onto. So for example, there are certain issues with this approach. You see that the surface there is a little bit crooked, and that is because, for example, this edge and there, how could I say that? When this face is being projected down and this face is projected this way, they can theoretically intersect each other. But there's a very simple workaround. So all we need to do, so you see like the moment I, for example, make those faces look more not tangent, perpendicular onto the surface it should be projected on. So in even best practice, all I want is that actually the objects are nearly parallel to the surface I should project onto. I get very good clean results. So now for the software, it is really very easy to understand how, for example, this band should be projected onto my surface. And that is what you can use the direction function for. Basically, you model a surface around your object and try to, when you build it, try to follow the object's own surface or surface flow, and this way you can then make sure that actually everything follows nicely. So you see here, for example, I projected a little bit of geometry out and kind of like built a piece hovering on that surface. Now, when you use Y, for example, it works a little bit different. Y is actually a very simplified approach. So, for example, all Y allows me is kind of like project something straight along the Y-axis. So, for example, how a face is oriented doesn't really matter because those points are being straight projected along the Y-axis. So, for example, if I extrude this one out and extrude this one out, there you see like how perfectly it fits on it. Think about this kind of like a projector that really goes just along one direction. But you notice the moment a little bit of geometry it has no target behind, this projection fails. So if I move this one slightly down at one point, dang, see there, it fits. So this is, for example, a really easy way when you use Y, when you want to project something linear as accurately as possible onto a curved surface. So for example, that is what I did here with my party lines. And if, for example, you would like something to flow around your object, like this part, then you should best not use the axis constraint because it will not allow you to model the surface around your object. And then you can basically, kind of like build a piece of clothing you put around your car and then snap onto the object. The only thing that's very tricky sometimes is, for example, you see here in my case, if I draw some lines and some lines, kind of like those are helpers, I can see that actually those parts here I have to move up a little bit. And I have kind of like a small dent here. So there are some limits or problems to it because again, it's not using kind of like a linear projection. It is using how the face is actually looking at a surface. So while to a certain degree it allows me a little bit of flexibility, there are also some issues, and unfortunately the way how this works. But this is, for example, is like a tiny detail, and just for the conceptual part, it's okay to work with this. And that's also a problem, for example, with this here, which we will solve actually with a process in Fusion. So this was actually everything so far for the modifier, the shrink wrap, how to use it.